Hi everyone and welcome to my video on combining events, part of the probability series for, well, what is it? Mathematical Methods Units 1 and 2. And you're probably turning around going, but hold on a moment, I'm doing A-levels or I'm doing a completely different course. Doesn't matter. Probability is probability regardless of where you are. And this stuff is incredible. I'm going to say that anyway. Now, my name is Darren from Maths Guru. Yes, that was funny in 2013, but now no one can spell it. And I'm here trying to make maths as engaging, as interesting as I can, but also deep enough that you can smash any exam possible. How do I do that? Well, the learning objectives behind me is certainly one way, because that's what we're going to go through. But all of this stuff is downloadable from maffsguru.com. And there are all of these videos sequenced against Cambridge, and there's downloadable lesson notes. There are VCAA exam questions, and there is so much more coming. All right, so that is there for you. But my learning objectives: understand what it means to combine events in terms of probabilities, understand what the following means. Mathematical methods is all about the language, and if you understand the language, pretty much you can smash any of this. So an empty set, a union, an intersection, a complement, disjoint, and also later on what the addition rule is. Now, again, we've probably done this before in previous year levels. I know for a fact that those graphs there you will have seen hopefully before. Maybe the idea of the complement, maybe not. That one there, maybe not. But again, we've done Venn diagrams in year 10, possibly even year 9. So this is a recap, but taking it a bit further. Mathematical methods is about notation. It's about getting it right. So you notice all of these little epsilons, which should be beside all of them. Yes. That is telling you that that is your sample space. This thing around here is really important. Doing the epsilon, really important. Understanding the notation, really important. So let's build on what we already know and extend it a little bit more. Now, something you may not remember is this one here. And there is a subtle difference between when there's an N outside and when there is a PR. Now, N literally means the number of, right? So if we have some sort of sample space or some sort of event A, and you're looking for N, it's just the number of numbers, if you were, in that set. Nice and easy, but it trips people up, or it tricks people a lot right and center. Probability, well, this would be a probability of some sort of event happening based on your sample space, based on something, who knows? But it's important to know the difference between N and PR. So looking at question number 1, 50 students. Oh, that's quite important. Hold on a moment. 50 students were asked what they did on the weekends. A total of 35 said they went to football matches, the movies, or both. Of the 22 who went to football matches, 12 said they also went to the movies. Right, okay. Show the information on a Venn diagram. Well, the first thing I know is a Venn diagram has a beautiful rectangle. Thank you very much. It's going to have an epsilon there. And now going to try and draw 2 reasonably large circles that are going to intersect, because that overlap is important. Actually, that's not bad if I do so myself. I'm okay, the circles aren't the same size, but we'll cope. Right, 50 students in total. N equals 50. So we have a total number of 50 students there. What does it say? A total of 35 said they went to football matches. Right, okay, so we've got 35 inside. That's what that's telling you. That this section here, plus this middle bit, plus this outer section must total 35. Well, hold on a moment. That means that automatically I must know that I've got 15 sitting in this outer set. Now, what does that stand for? Well, that's the people who don't like football or the movies. So we need to make sure that we label F and M to say what these individual circles stand for. All right, what does it say here? So of the 22 went to football matches, 12 said they also went to the movies. That is code for saying that section is 12. Right, there's that 12 overlap. But what does the 22 mean? Well, the 22 means that this whole circle, that's this middle section and this section here, must add to 22. Well, if I've got 12 there, hopefully some pretty rudimentary maths means that's got to be 10. Cool. Right. Well, how many are going to the movies? Well, again, we come back to this idea here. 35 people have to fit inside this section here. I've got 10, 22, so 22 to 35 is 13, and there we go. That must mean there's 13. Now again, just checking, 13, 25, 35, 45, 50. We've got all the people in there. Now that we've drawn our Venn diagram, we can answer our questions. Nice and easily, he hopes. So let's say part A, what do we got here? How many students went to the movies but not to football matches? So movies, but not. So I can't have any overlap with football. It's got to be just this section here. And so in which case my answer to A is going to be beautifully 13. And what about part B? How many went neither to football nor the movies? Well, that's basically saying the outer section and 15. Now, is that going to be correct? Possibly, but maths is about the notation. So maybe for part A, what we should have written was N, and in brackets, what does it want? How many students went to the movies, but not football matches? So M and not F, all right? So M and not F would be 13. And how would we give the notation for the next one? So it's neither, all right? So basically that would be not the movies and not football would actually be 15. Notation is so important in this course.